Hello students, today we will continue to study exhaust devices. This is the third section of our exhaust device class, which is also the last section of this chapter. We will learn about the sources of engine noise and silencing measures. Noise is generated by airflow with unstable speed and frequency. The noise sources of aircraft engines include fans, compressors, combustion, turbines, and exhaust flows. According to the different principles of noise generation, we can divide engine noise into three categories. The first is the noise generated by the mixing of the ejected high-temperature and high-speed combustion gas with the outside atmosphere, which is also the main noise of the engine. The second is the noise generated when the air enters the intake duct and flows through the engine. The third is the noise generated by the vibration of the engine. According to the principle of engine noise generation, we have summarized three methods of noise reduction. First, reduce the speed difference between the exhaust flow and the atmosphere. Second, change the frequency of vibration. Third, use sound-absorbing materials. First, let's introduce the first method of noise reduction, which is to reduce the speed difference between the exhaust flow and the atmosphere. Because the energy level of noise is proportional to the eighth power of the jet speed, the higher the jet speed, the greater the noise, so reducing the jet speed a little can greatly reduce the noise. It includes two types, turbofan engines and internal exhaust mixers. The high thrust of a high bypass ratio turbofan engine is mainly achieved by the large airflow rate. Compared with a low bypass ratio engine, its airflow speed is lower, so the noise generated is also lower. Some high bypass ratio turbofan engines use internal and external bypass exhaust mixers for noise reduction. They can complete the mixing process of the hot, high-speed airflow and the cold, low-speed airflow of the internal and external bypass in the engine, reduce the minimum speed of the exhaust airflow, and achieve the purpose of reducing noise. The second method of noise reduction is to change the frequency of vibration. The propagation of noise is related to the frequency of vibration. High-frequency vibration is easily absorbed by the atmosphere, so the distance of high-frequency vibration propagation is not far. Low-frequency vibration is not easily absorbed by the atmosphere, so the distance of low-frequency vibration propagation is far. Using this principle to convert low-frequency vibration into high-frequency vibration, three types of tail branch pipes are designed, namely, the pattern tail nozzle, the new tail nozzle, and the tube tail nozzle. The third method of noise reduction is to use sound-absorbing materials. The principle of sound absorption is to convert sound energy into heat energy. Installing sound-absorbing pads on the wall of the engine where noise is generated can reduce some noise. The sound-absorbing pads are composed of porous skins that are connected together, a sandwich layer of honeycomb structure and a bottom layer. The small holes on the skin play a role in reducing the viscosity of sound waves. The cavities of the honeycomb can adjust certain tones in the noise spectrum and weaken them. Students, this class is over. We have completed the study of all the contents of the exhaust device chapter. Students must master today's knowledge in time and apply it to other situations. Thank you.